Hello everyone, you are welcome to Science Explained. Today, I want to start treating the topic trigonometry. Why did I decide this? Simply because I realized that students find this topic very challenging as a result of poor understanding of the rudiment of this topic. Therefore, I am starting today from the root. From the root to the top. And I am going to divide it into episodes by episode. Meaning that if you can try as much as possible to follow from episode 1 to the end, I don't know myself how many episodes I'm going to have to contain or to complete the whole topic. But I can bet it with you that if you can follow from the first to the last episode, you won't have any reason to have any difficulty understanding this topic henceforth. Now, what are the things you need to know first? Whatever I'm going to do today will be the basic information on trigonometry. Under trigonometry, we have the following 6 trigonometry ratios. Six trigonometric ratios. And the 6 trigonometric ratios are these: sine, which is found using opposite over hypotenuse in a right-angled triangle. In a right-angled triangle, take note of that. Cosine, that is adjacent over hypotenuse. Then tangent, which is opposite over adjacent. All right. The reciprocal of these 3 trigonometric ratios will give us the remaining 3 trigonometric ratios. And what are they? Secant, which is 1 over cosine. Please take note of that. Inverse or reciprocal of cosine. Yes, reciprocal of cosine is secant, not inverse. Inverse is different from reciprocal. Cosecant is a reciprocal of sine, that is 1 over sine. And cotangent is a reciprocal of tangent. So if you understand this, what I mean by this is that when sine is opposite over hypotenuse, cosecant will be hypotenuse over opposite. That is the meaning. Cosine is adjacent over hypotenuse. Definitely, secant will be hypotenuse over adjacent. The same thing, tangent. This is a certain form of tangent. Tangent is opposite over adjacent. That means cotangent will be, which is 1 over tangent, will be adjacent over opposite. That is what we mean by reciprocal. So I will be using this shortened form. This is a shortened form for sine. Cosine, I'll be using this shortened form. Tangent, I'll be using this shortened form, which is universally accepted. Tangent, that will be tan. Then secant, that will be sec. That's the shortened form of it. Cosecant, I'll be using cosec as the shortened form. Cosec. I would like to rewrite up here so that you can see everything in detail. When you say cos, it means cosine. When you say sin, it means sine. When you say tan, it means tangent. When you say cot, it means cotangent. When you say secant, that's sec, it means secant. And when you say cosec, it means cosecant. Please take note of all this. Alright, having said this, what is the next line of action? Lest I forget, do not forget that I said the formula given for sine, cosine, and tangent are only applicable to right-angled triangle. This is a right-angled triangle. So, if this is angle theta, then this one here will be opposite because it's facing this side. The longest side, which faces the angle 90, is the hypotenuse, while the third side will be adjacent. Meaning that if I am using this angle as alpha now, then here will be the opposite to this alpha, while here will be adjacent to this alpha. So, you have to note that. It means that the angle you are dealing with determines where is opposite, where is adjacent. But all in all, in a right angle triangle, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. This is what we call four quadrant. Four quadrant. The zero angle starts from here and we move anti-clockwise for the positive direction. But if the angle given is negative direction, this is for positive. While if you go this way, is for negative angle. Alright, so sine, cosine, and tangent of any angle between 0 and 90 will give you a positive value. That is the meaning of sine, cosine, tangent being here. For example, sine 60, cosine 60, tangent 60. Because it's less than 90, it will be positive value. It will give you. But when you get here, any angle that is greater than 90 less than 180 will give you a positive value if you are checking the sine of that angle. But if you are checking the cosine or tangent of any angle within this quadrant, it will give you a negative value. For here, any angle greater than 180 less than 270, tangent of it will give you a positive value, while sine and cosine of it will give you a negative value. We are going to have a look at many examples. Now, lastly, cosine of any angle between 270 and 360. Don't forget, more than 270, less than 360 will give you a positive value. But if you check the sine and tangent of it, it will give you a negative value. Now, I want to talk about boundary angles. What do I mean by boundary angles? The angles that you can find on the lines dividing the quadrant, horizontal line and vertical line. So those angles are 0, 90, 180, 270, 360. All right. Now, for the horizontal, if you look at it here, horizontal line here connect 180, 0 and 360. Cosine claims this line. How? If you check for the cosine of 180 degree, cosine of 180 degree, to give you negative 1. That's why I put negative there. Because if you check for the cosine of 180 using your calculator, it will give you negative 1. Because according to your graph, the horizontal axis has negative value on the left side, positive values on the right side. That means if you check for the cosine of 0 degree, because 0 is on the right side of the horizontal line, it will give you positive 1. Same thing, cosine of 360 degree, it will give you positive 1. Now, you might not be asking me, what happens to to sine of these angles? All of them will be zeros. Sine 180 will be 0. Sine 0 will be 0. Sine 360 will be 0. Why? Because sine does not have a claim on this line. Take note of that. Now, let me now talk about the vertical boundary line on the quadrant, which is this. You can see that the vertical line connects 90 and 270 degrees. The claimer of that boundary line is sine. Now, according to your graph, the upper side of the y-axis is positive, while the lower side is what? Negative. It means if you check for sine 90 degrees with your calculator, it will give you positive 1. While sine 270 degrees will give you negative 1. So please, let's take note of this. Lastly, on this episode, you should know that all angles in degrees can be converted to radian, which is mostly used in calculus and other advanced mathematics. Now, 180 degrees is equal to pi radian. Please take note of that. So if you multiply 180 by 2, that will give you 360. That means that will be 2 pi radian. Because 360 is 2 times 180, that will be 2 times pi. If you divide 180 by 3, that will be 60 degrees. That means 60 degrees will be pi divided by 3, which is pi over 3. So this is what I'm going to discuss in the next episode. How to convert angles in degrees to radian, and how to find the values of the trigonometric ratios of angles. So meet me in the next episode, which is going to be episode 2 on trigonometry. If you appreciate this teaching, please do not hesitate to subscribe to my channel for subsequent release of videos. See you next time.